Our Earth, the only livable planet in our solar system, beautiful and picturesque, or so it seems. Every year, the minimum amount of people that are killed by our Earth through volcanoes, earthquakes, and tsunamis is approximately 10,000. These occur because of tectonic plates. The Earth has not always been this way. Millions of years ago, our Earth was not split up into 7 continents, but one supercontinent, Pangaea. But why is Pangaea no more? The Earth is made up of different layers: the inner core, the outer core, the mantle, and the crust. The crust is split up into 2 parts: the lithosphere, which is on top, and the asthenosphere, which is below. The crust is made up of tectonic plates. These plates move, converging, diverging, and subducting to create natural disasters like volcanoes. Volcanoes are formed when an oceanic crust converges with the continental crust. The oceanic plate, being denser, subducts into the asthenosphere. Over a long period of time, the broken crust slowly melts in the extreme temperatures, and the new rising magma rises through the lithosphere, collecting under the continental crust, leading to some earthquakes due to the movement of the magma, causing the crust to swell as the magma increases. Pressure from the trapped gas gains on weakened spots. Over a time period of 10,000 to 500,000 years, these magma chambers form and threaten to erupt at any time. There are also divergent volcanoes, formed by tectonic plates pulling apart, and magma rises up through the cracks and form a new crust. Volcanoes that have not erupted yet, but have been shown to, are identified as dormant volcanoes. Older volcanoes that are no longer in the hotspot for volcanoes have stopped erupting, become dormant. An example of a dormant volcano is the Mauna Kea, found in Hawaii. Being over a million years in age, it last erupted over 4,000 years ago. An, ex- an extinct volcano has not erupted for as long as 10,000 years and is not expected to erupt in the near future. They become extinct when the magma supply is cut off from the volcano. However, there are many extinct volcanoes that have erupted. Humans cannot predict when a volcano will erupt. On Earth, 600 million people live close to active volcanoes. Volcano risk management and separation are becoming more important as volcanoes disrupt travel such as planes, boats, cars, independent trains, and apps. Over 20 large volcanic eruptions have occurred in 2015 alone. Mount Merapi killing over 353 reported people. Recently, Mount Sinabung in Indonesia erupted, delaying many plane flights and leaving passengers stranded. With an unpredictable
Earthquakes, killers, and destroyers. But how do they actually happen? In short, earthquakes are caused by plate tectonics. An earthquake is when rocks underneath the earth are under stress. This then causes movement, which causes seismic waves, which travel for kilometers. Earthquakes can happen anywhere, but mostly occur around the plate boundaries. The tectonic plates are always moving. This creates a large amount of stress. The strength of an earthquake is called its magnitude. This is measured on the Richter scale. Earthquakes are recorded by a device called a seismograph. These devices have been used for years. The devices measure all types of seismic waves, such as P waves, I waves, and S waves. This has been shown on the screen. Earthquakes have an epicenter. This epicenter is the surface focus, the place where the earthquake starts, or where we can feel it. When an earthquake happens underwater, though, a new force is unleashed: a tsunami.
Tsunamis are one of the world's most deadliest natural disasters. They are destructive and powerful. Tsunamis around the world claim extensive amounts of lives each year. Tsunamis can be defined as a large or tidal wave caused by a subducting tectonic plate sliding beneath an overriding tectonic plate. With time and pressure, the overriding plate suddenly slides on top of the subducting tectonic plate. This movement uplifts the body of water, followed by a quick descent. This action displaces the water, causing it to peak normal sea level. Tsunamis can travel extensive amounts of distance, gaining power and speed as land is reached. Tsunamis can be formed when an undersea earthquake takes place. This action is the ocean's lithosphere plates sliding past one another. This movement causes one of the plates to move upward, taking the huge body of water positioned on top. Tsunamis can also be formed by volcanic activities. Volcanic tsunamis are the result of submarine explosions. Submarine explosions are eruptions that occur beneath the water surface. These eruptions take place at constructive margins, subductions of water. A coastal landslide can also form a tsunami. This type of tsunami is caused when sediment builds up in an area of the ocean, causing a shelf-like passage. The cause behind tsunami's destruction is the wave gradually travels into shallow water and rises, peaking major heights and breaking. This action causes a flood of power and force to erupt on land. Tsunamis are known for their destruction. Some major tsunamis in the past are the Indian Ocean earthquake and tsunami. This earthquake is one of the most destructive natural disasters known to man. The earthquake at magnitude 9.1 hit Somalia's west coast in 2004. After the quake, a dozen tsunamis followed. The tsunami itself reached Indonesia, India, Sri Lanka. The Lisbon earthquake and tsunami. This earthquake was an extremely destructive natural disaster. The earthquake at magnitude 9 was located in the Atlantic Ocean in 1755 and slammed into Lisbon and Portugal. A massive tsunami followed the earthquake. Its effects were seen in Spain, Portugal, and North Africa. In total, 10,000 people in Lisbon died. The Arica tsunami. The magnitude 8.5 earthquake smashed into the southern coast of the Peru-Chile Trench. Immediately after the quake, a mega trans-Pacific tsunami crashed into Arica. To conclude, how harmful could a little bit of water be? Extremely, when the force of tectonic movement is behind them.
When an underwater earthquake occurs and is recorded by the global network of seismologists, a siren will go warning of a fast approaching tsunami. Exactly how does it work though? The first part of the process is much the same as how an earthquake is recorded. All around the world, there are seismic stations. These can locate where the seismic activity occurred. So, if an earthquake occurred in the ocean, the second process begins. Our tsunami model is created based on the information from the sea monitoring. This model shows how much impact the tsunami is and if it is going to happen. Finally, the siren will wail, alarming the people in the nearby area of the disaster that's about. Our Earth is constantly moving, sometimes causing mass destruction through volcanoes, earthquakes, and tsunamis. But if technology advances significantly, will worrying about natural disasters be a thing of the past? Will mankind have to survive on a new Pangaea?